Okay, we're in section 85 now. As always, there'll be contents for you to look at, examples for you to do, exercises to work on. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, which dates back to 1904. This PDF that you're seeing on the screen right now is being made available to the Prison Mathematics Project participants only. Right. I realize there's other people watching the videos, and any students and teachers out there interested in getting a copy of this, it will be published. It's just not published yet. If you need to reach out to me, tell me you're interested in that. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right, let's take a look, see what they're going to do over here. This is a technique. It's a technique to earn undetermined coefficients. It's a technique to generate a series. All right, so I'm going to say we want to use that technique, of course, and see what it entails. All right. Now, certainly we'll take examples. I'll walk you through these examples. I notice that I just highlight the quote here. I'll read it to you. Those who will not reason are bigots. Those who cannot are fools. And those who dare not are slaves. All right. What the whole point of mathematics is to reason. So I'm going to try to reason through what Wells presented. And what Wells presented, he says, this rational function over here, he's saying that he's going to be able to expand it into an infinite series. Now, I'm not saying it's going to be expanded into an infinite series true for all x. I'm not concerned about that. What I'm concerned about is it's going to be expanded into a series where there's going to be coefficients. I just don't know what the coefficients are. So I'm going to say maybe a constant, it might be 0, but anyway, then another term, I'm going to say bx, and then another term, I'm going to say c, and these are coefficients I don't know, but I do know what series look like. It looks sort of like this over here. And this goes on forever. Now, I'm not saying this is true for all x's. I'm just saying there's going to be some interval where this would be true. All right? Now, the assumption is that you probably could get the coefficients just by equating this over here. And what I mean by that is that you could do something really, really simple. And what I mean by simple over here is you could look at this and say, how can I get these guys to disappear? And you could get those guys to disappear. When they disappear, you'll know what the A is by choosing x to be 0. So the first thing I would do is I would choose x to be 0. And when you do that, what do you get on the left side? You would get 2 over 1, which is 2. So now I know what A is. I know the A is 2. And that was really simple. So I've determined one of the coefficients in the problem. I've determined that the A is 2. All right, and that's an important first step in doing these problems over here. Are there other ways of doing the problem? Yeah, and I'll discuss that. But right now, I definitely got A to be 2. All right? So what I want to do is I'm going to erase this chicken scratch up here. And I'm pretty convinced that A is 2. I'll show it in the work, by the way. I'm going to erase my highlighting over here, too. No need to highlight that anymore. Again, we're trying to reason. Okay, so I got the A to be 2. And now what you're going to do next is you're going to clear the fraction. And to clear the fraction, I want to point out you're multiplying both sides by the LCD. And this is the part where a lot of students get very confused. So when I multiply both sides by LCD, what do I get? I get 2 minus 3x squared minus x cubed equals, well, it's going to be 1 minus 2x plus 3x squared times, I always find this difficult to do, by the way. I do know A is 2, though, right? So 2 plus bx plus cx squared plus, I think you get the idea. It goes on, right? So I don't want to write them down. I know what they are, though. I know what they are. But now the problem still remains. I don't know what B is. I don't know what C is. But I do know something over here. I know that B is the coefficient of the linear term. So I'm wondering what the linear term would be. Right? And I got to figure that out now. And the way I'm going to do that is I'm going to start to multiply. All right? Now, if you multiply, I hope you realize, you would distribute the 2 across a bunch of terms. But I'm just looking for the linear factor. All right? Now, someone says, why are you doing that? I notice on the left side that there is no linear factor, right? Now, I realize what some students want to say. They want to say b is 0. I didn't say that. I'm just saying that. I'm just looking at the linear factors now. And I'm looking at the 1 now. And so you would definitely get bx. Right? I wouldn't do 1 times 2 because there's no x in that. But I do 1 times bx. And I wouldn't do 1 times cx squared because that's not x. That's x squared. And now I'm going to distribute this term across. And what would you get? Well, you'd get minus 4x. But after that, what would you get? You'd get, well, you get a quadratic and a cubic. So I don't think I want to write that down. So let me see if I can figure out what the b is in this particular equation. And it looks pretty easy to me. I'll tell you why. What do I get over here? Well, I get bx minus 4x. Well, the b's got to be 4. I'm hoping that's clear as day to you. All right, so I'm going to get my eraser out. And I'm going to erase this over here. And I know this is 4x now. Now, it's tough. I'm not saying it's easy. We have other ways of doing it. Don't worry. All right. Now, of course, I'm done with that linear term. I'm going to erase this chicken scratch over here. And I want to go to the quadratic term. And someone's going to say, is there a quadratic term in the left? And there is. And what's that quadratic term in the left? It's minus 3x squared. Now, I need to look for the quadratic term on the right. And 1 times 2 doesn't fit the bill. 1 times 4x doesn't fit the bill. Let me erase these checks up here. But 1 times cx squared fits the bill. So I'm going to write that down. Now I'm going to do the distribution of minus 2x, and I'm looking for a quadratic term. Minus 2x times 2 is minus 4x. That's not a square term. And the next term I'd get is minus 8x. This gets tough, by the way. Minus 8x squared. And if I continue to do the minus 2x across those terms, the degree gets bigger and bigger. So now I'm moving on to 3x squared. And what do you get? You're going to get 6x squared, and then a bunch of terms that are higher degree. So I got something over here. I'll tell you what I got. I got coefficients. And one point I'm looking at, they're all x squareds, by the way. I'm seeing minus 3 equals c minus 8 plus 6. I'll write that down for you. Minus 3 equals c minus 8 plus 6. Well, I'm going to see if I can figure out the c. I think it looks pretty easy, though, right? You get c. This would give you minus 2. And I'm going to add 2 to both sides, and you get minus 1. Right, I'm going to erase that now. I know it's tough. It's tough for me, too, by the way. So I'm going to say I think c is minus 1 now. And again, we have other ways of doing this. All right? So someone's going to say, you know, what are you going to do now? I'm going to do that cubic term. All right? So let me kind of erase. And this is not easy. I'm erasing my chicken scratch. And I want to start doing the cubic term now. All right? That's going to be minus x cubed on the left, right? Well, 1 times 2 is not cubic, 1 times 4x is not cubic, and 1 times minus x squared is not cubic. What's the term that went there, if you recall? Well, that was dx cubed, right? Hope you remember that. So what do you get? I get 1 times that, which is dx cubed. So I hope you realize what we're doing. We're kind of going through these coefficients one at a time. A, B, C, D. We're on D now. And I'm still looking for more cubics. So I did the 1, now I'm on to the minus 2. You get minus 8x squared. That doesn't seem to do anything for me. Minus 2x minus x squared, though, is going to be what? That's going to be what? Plus 2x cubed. And then I'm going to do 3x squared times 2. By the way, every term after that's higher degree, so I'm not going beyond that. Then 3x squared times 2 is 6x squared. That doesn't fit the bill either, does it? But then 3x times 4 is 12x cubed. I'm going to start to equate coefficients now. Minus 1 equals d plus 2 plus 12. Well, looks pretty easy, doesn't it? Minus 1, d plus 14. So what's d going to be? Minus 15 equals d. So I think I know at least some of the terms. Now, sometimes because you can keep doing this, of course I can. You can keep doing it as long as you like. But I want to point out, I'm going to expand it, not too far. I don't want to go too far with it, but I got to start it, right? So what would I start with? I'm up to that d now. I got the d term. So I'm going to say, looking at it, I'm going to say, and again, I'll show you a different way of doing it. 2, we'll check the key later, plus, I'm just copying this over here, by the way. 2 plus 4x minus x squared. The d turned out to be minus 15, right? You know, let's do one more. I noticed I got one more there. Let's do one more. All right, let me, kind of running out of room, right? Let's have more paper. But what was d? D was minus 15, right? So I'll put that down. And then we got an added term on, right? You know what, I'm going to just pull it over a little tiny bit. And then we're going to add on, right? We get that a fourth degree term, and that's going to be e x4, right? Let me get my eraser out. Erase my chicken scratch from that d problem. And I'm going to put down the fourth degree term. And again, this goes on forever. Right? Now, what's the fourth degree term on the left side? It's 0, right? There is no fourth degree term. Well, I'm going to distribute the 1 across those terms until I see a fourth degree term. And the first one I'd see is e x4. What's the next one I'm seeing? I'm getting a little better at this, by the way. The next one I'd see is, let's see, I guess you'd see 30, right? x4. And then get the 3x squared, that would be 12. Nope, that's not 12. That would be 12x cubed. I don't want that. I want the fourth power. That would be minus 3 x4. I'm going to equate coefficients. 0 equals e. Well, I can get better. 30 minus 27 is what? I'm sorry, 30 minus 3 is minus 27, right? So what's e? Did I make a mistake somewhere? I'm sorry, plus 27. What's e? Because 30 minus 3 is plus 27. E is minus 27. I think I was looking forward to that. All right, so I know the e now. What's the e? The e is minus 27. You could imagine that this could go on for a very long time. I got to be honest with you, machines can do this pretty quickly. I do want to point out another way of doing it, and the other way of doing it is just by long division. I find long division a little bit easier, but that depends. So it's good to have choices. Sometimes long division is easier, sometimes equating coefficients is super easy. So what's a long division? I'll write down for you. 1 minus 2x. We are going to get the same result, plus 3x squared. We're going to be dividing it into a polynomial, 2 plus 0x. There's a reason for this, by the way. Minus 3x squared. You do not have to put the 0x in if you don't need it, by the way. Minus x cubed. Well, what times 1 would give you 2? That's 2. That's pretty simple. What do you get? 2. 2 times minus 2 is minus 4x. Then you get 6x squared. Let's see if I did that right. 2 minus 4x. Yeah, I did okay. I'm going to subtract. You get 4x minus 9x squared. I'm going to drop a place down. Again, I find this easier to do. You have to decide what you like doing now. I do think you should learn undetermined coefficients now. What's the next thing? Well, what time do I give you 4x? Let me see if I did that right. 4x. I got a slight problem here with the division. And what I'm going to do, did I do that right? Did I copy right? 2 minus 3x squared minus x cubed. 1 minus 2x plus 3x squared. That's 2 minus 4x plus 6x squared. I got the 4x. Oh, you know what? I copied wrong. I just noticed that. I said 4 and I wrote down 2. And the reason I said that, I wasn't expecting a 2x. I was expecting the 4x there. And that's why I paused for the moment. Again, we did that before. Remember that? That's right up there. I just copied wrong. That's all happens there. So, what times 1 will give you 4x? And that's why I paused there. So I put down the 4x now. Hey, it can't hurt to do it twice, You did it the undetermined coefficients. I'll do long division. They got to match. So what do you get? 4x. And then you're going to get minus 8x squared. And then you're going to get plus 12x cubed. And what do you get there? You're going to get minus x squared minus 13x cubed. Well, let's repeat. What times 1 will give you minus x squared? That'll be minus x squared now. What do you get there? Minus x squared. We got to be real careful here, by the way. Plus 2x cubed. And then you're going to get minus 3x4. I'm going to subtract. Yeah, your mileage may vary. You may say, I don't enjoy doing this. It's possible. Minus 15x cubed. It's good to have options, though. Minus 3x4. Mistakes happen, and you want to practice. So what do you get? I guess minus 15x cubed now, right? So that's going to give you a minus 15x cubed. Let's see. That's going to give you a 30x4. And then you're going to get minus 45 x5, right? Let's subtract. I'm kind of running out of room on the side there, so I'm going to pull it over a little bit. That's going to be, let's see, what is that going to be? Did I do something wrong again? Minus 15x squared plus 30x4 minus 45. I think I might have done something wrong. Let's see what I did wrong. Minus 15 is 30. The reason I said I got to match, it's not matching at this point. And I got to see where I went wrong. Minus 15, I think I did it right there. Minus 3x4. Oh, I'm sorry. You know what I did? I didn't subtract right. That was my problem. That was crazy. All right, but I'm glad I did it both ways, because I really see my errors when I do it both ways. Much more clear. What do you get over here? You're going to get minus 27 x4 plus 45. And I did make a mistake before, and I'm glad I caught it. And then what are you doing? You're going to repeat, and what's that next term going to be? Minus 27 x4. Right, we're getting what we matched up over here, and that's good news. All right, let's do the next one. Next one, again, you're looking at saying, is it the same question? It sure does look like the same question. So I'm going to say, I think I can write this down. Kind of series. And I'll go through the work with you. Again, you don't need to watch these videos if you're watching this and saying, gee, I could do this without watching you. And that's fine. Some people need to watch. Some people don't need to watch. You do what you need to do to go forward. Don't think you have to do one thing or the other. You got to do something to move forward. So I'm going to do something I did before. I'm going to set x to be 0. And what do you get if you do that? Well, lo and behold, you get a really simple number. And they're awful kind about it. Right? So if I chose x to be 0, I'll write this over here. If I choose x to be 0, Someone says, why are you doing that? I want these to disappear. There's an infinite number of terms there. Disappear when x is 0. Every term has a factor of x in it. And on the left side, what do you get? You get 2 over 1, which is 2, so a is 2. This is good news. Now, someone says, I can't remember what you did. Well, that's why you study these problems over here. What do we do next? We multiply both sides by the LCD, with the understanding that a is 2. Right, I'll write that down for you. And that's going to be 2 plus 4x squared minus x4 is equal to 1 minus 3x squared plus 5x4 times, and I'm going to start equating coefficients in a moment. I got to write this down, by the way. And, I noticed they did something unusual over here, but I got to be honest with you, I'm not going to do that. And the reason for that is, I noticed what you're doing. They got x squared, x4, x6, x8, and I know why they've done it. They're all even powers, but I'm still going to write this down. All right, everything's an even power, but it doesn't matter to me. And I'll write this over here for you. And what am I going to write down? I'm going to write down what I said originally. All right, a little different, but we get the same answers. What are you going to get over here? Well, I turned out the a is 2, right? Then you get 2 plus, right, bx plus cx squared plus dx3 plus ex4 plus fx5. You get the idea. It goes on forever. Now, someone says, what are you going to do now? We're going to equate coefficients. So I've already have the constant part done. I'm going to do that. The first thing I see is I see 4x squared. Before I see the 4x squared, though, what becomes 4x squared is there should be no x's. All right, let's go through that. Now, where would I see an x? Well, let's take a look. Not 1 times 2, right? But 1 times bx would give you an x. And anything that's higher degree. Now, that's about it. So what's b? B has to be 0. All right? So that's really falling back on what they're saying, that there'll be no odd power for x. So I'm just going to erase this over here. The b is gone now. The b is 0. All right? That was pretty easy. All right? I'm going to erase. And this is my chicken scratch. I'm going to erase this over here. That was easy. And now I'm going to go on to the square term. And the square term on the left side is 4x squared. Now I got to go to the right side and get square terms. Well, it's going to be 1 times cx squared, right? So that'll be cx squared. Now, is there any other square term? And I think there is. It's minus 3 times 2, which is minus 6 x squared. We have an edge key to check, so I know if there's a mistake, I'll find it. The other thing I want to point out to you, I bet these are going to be really nice numbers. All right, I'm going to equate coefficients for you. That's going to be 4 equals c minus 6. And I'm going to say c looks pretty simple to me. It looks like 10. So I'm going to erase. And I'm going to put plus 10 now. Let me get my eraser out and erase my chicken scratch. This is not easy, is it? Now I notice that on the left side there's no cubic terms. So I'll write that down for you. So what's a cubic? There's no cubic terms. They noticed that from the beginning, by the way, but let's not worry about that. So I'm going to look, see if there's any cubic terms, and what I get. Well, I do get a cubic term over here. What do I get? 1 times dx cubed, which is dx cubed. Is there any other cubic term? And I'm not seeing it because I got minus 3x squared next, and I see no other linear factors to give me a cubic term. So d has to be 0. So I'm going to erase I know the d is 0 just looking at this equation over here. And I'm going to erase this over here. So there is no term with an x cubed in it. And again, they notice that from the get-go. Now I'm going to go to the 4th power. And I'm looking at it. And what do you get in the left side for the fourth power? Minus x4. All right, now let's look on the other side, and I'm going to look for a fourth degree polynomial. And what do you get? I'm going to do the one first. I'm seeing ex4. And after that, they're all bigger than 4, so I'm not going to go with that. Then I got the minus 3x squared times the 10, which would be minus 30x4. All right? Now, everything after that's going to be higher than a degree 4. Now I'm going to move on to the x5, and what do you see? 5x4 is going to be 10x4 now. Yeah, 10x4. Well, I'm going to equate coefficients now. All right? I want to see how far they went out. No, they went out to 8. All right, we're on 4. Let's take a look at this. So minus 1 equals e minus, well, minus 30 plus 10 is minus 20, right? So e is going to be 19, right? So let me get my eraser out. Just give me a second. I'm going to say e is 19. All right, I'm going to erase a few other things over here. And I'm going to try to neaten it up a little bit because I know they went up much further than to that power. That's fourth power. All right, I'm not saying it's easy, by the way. You'd be shocked how fast machines are at this, though. But I'm going to clean it up a little bit. And as I do that, I'm just cleaning it up. 19x4. And I'm starting to catch on to that even power business now. So I'm just gonna write down even powers now. All right, so I'm changing my mode from this up here now to saying I know they're just even powers over there. Right? Again, when I started, I didn't know that, but when I start working on it, I see that, right? So what's it gonna be? I'm gonna write this down now. Bx squared plus cx4. I'm changing the letters, by the way, because I'm getting rid of all those odd powers. x6, ex8. So I'm going to continue to write that down now. I'm updated because I'm starting to see things now. I see things by doing things. So what do you get over there? Well, it's going to be d now, right? dx6. And it goes on forever. I'm not saying it doesn't. Yada, yada, yada. All right, let's do the next term up, which is, I don't know the sixth degree, but I do know on the left side there is no sixth degree. But on the right side, what would it be? It would be 1 times dx to the 6. Are there any other terms in a multiplication that produce a 6, though? Well, I'm going to go to the minus 3x squared. So that'll be minus 3x squared times 19x4. Well, 3 times 19, that's going to be 57, right? Don't worry, you have an H key to check. And everything up from that is going to be definitely a higher degree. Now I'm going to go to the 5x4, and that would be 50. x6, and everything above that's higher than the 6th degree. So I think I did okay here. I'll write this down for you. This would be 0 equals d minus 7. So d would have to be 7, right? Yeah, to get 0. So let me get my eraser out, and I'm going to say d is 7. I'm going to erase my chicken scratch because, you know, I don't need to look at it, right? I'm pretty convinced of that. Now, could I be wrong? Of course I could. I'll be honest, if I'm wrong, everything that follows is going to be wrong, which is not nice. But I do have an H key to look at later. All right? Let's go to the next one. And the next one, just looking at it, it's going to be the 8th power. Well, on the left side, I don't have any 8th power. Let's do the right side. That would be 1 times e x8. Let's look for other even powers that are 8. So minus 3x squared times 7x6 would be minus 21. x8. So minus 3x squared times 7x6 is minus 21x8. Now I got to do the 5x4. That's 5 times 19, right? That's going to be 50 and 45, 95, right? And again, everything above that's bigger than a factor of x8. So I got something interesting over here. 0 equals E. And let's see, minus 21 and 95 is going to be what? That's going to be 74, right? Let me just make sure of that. 74, 75, 85. Yeah, 74. What's E? Minus 74. Let me get my eraser out. I'm going to erase this over here. And what do you get? Minus 74. I want to look at the key, by the way, and see if we did okay. We got the 2, 10x squared, 19x4, 7x6, minus 74x8. I also want to claim that you can do a long division. All right, I want to write the long division down for you, though. And again, I know this is tedious, and sometimes it's tedious to watch someone do something. We're not suggesting you have to watch, but some students don't have a choice but to watch. And I'll divide in. And let's write this down. 2, I'm not going to put placeholders in this time, plus 4x squared minus x4. So what times 1 gives you 2 is 2. By the way, we're going to match this. Okay, let me repeat this. I actually find division easier than equating coefficients. I make mistakes still, though. I really mean that. 2 minus 6x squared plus 10x4. We're going to subtract. You get 10x squared minus 11x4. What am I going to do now? Well, I got to match it. So it's going to be plus 10x squared. 10x squared minus, well, let's see. That's going to be minus 30, right? x4. And then you're going to get plus 50, x6. All right, I'm going to subtract. And what do you get? I'm not going to line them up anymore. You get 19, x4, minus 50, x6. Again, I find this to be quicker. Now, again, others don't find it to be quicker. They find it to be painfully difficult. So I'm going to write this down now. It's going to be 19, x4. And what do you get there? 19, x4. Okay, 19 times 3 is 30 and 27, 57, right? And 19 times 5, this should be reminiscent of what we did before, I guess, right? That's going to be 95, x8. You're going to subtract. And what do you get there? Well, let's see. That 19x4 disappears. You're going to get 7x6. And again, I'm not lining them up for a reason. I'm running out of room. That's why. Minus 95, x8. All right, let's repeat. How do I do that? I need a 7, x6. What do you get? 7, x6. Let's see, 7 times minus 3 is minus 21. x8. And then 7 times 5 is 35. And that's going to be 35 x10, right? And this could be done for a very long time. I'm going to subtract now. What do you get? Let's see, what would you get? You get minus 74. Let me just check that. 70, 80. Yeah, that's good. x8 minus 35 x10. All right. You're going to repeat. And what's that going to be? Minus 74 x8. Now, I'm not going to continue after. I'll tell you why. They didn't continue after that. You're going to be shocked by this, though. And I want to tell you what you're going to be shocked by. How fast machines can do this. How slow humans are at it. But I do notice that I'm getting the same answer every single time. Whether I'm using the undetermined coefficient or I'm doing long division, I get it every single time. But both methods are tedious. There's no doubt about it. So what I want to do is, this one, I got to be honest with you, it looks really bizarre to me. Even when they say, do this one over here, but I'm kind of looking at the top one is just 1. And I'm saying, if you want to divide, divide. I like dividing. I really do. But I want to try a different way. I just want to try a different way in this one. So I'm going to put this over here. I'm not going to do undetermined coefficients. I'm not going to do long division. I'm going to try a different way. And the different way for me, and again, it might confuse you. You might say, no, I don't want to do a different way. I want to do it the same way each time. There's nothing wrong with that, by the way. But I'm going to factor the bottom, and I get x squared, right? You see that? And then 3 minus x. Let's see if that's true. You get 3x squared. Yeah, it looks pretty good, over 1. Now what I'm going to do is I'm going to split it into 3 separate problems by using a method what's known as partial fraction. So I'm going to say this is probably going to break into x squared, and 3 minus x. What I don't know is I don't know the tops. So I'm going to say, hey, maybe it's A, maybe it's B, maybe it's C. And what's that supposed to be equal to? This over here. What I'm going to do now is multiply both sides by the LCD. And what would you get? You would get 1 equals, well, then you'd get A times x times 3 minus x plus B 3 minus x plus C x squared. Now what I'm going to do is I'm going to pick some really easy values for x to see if I can find out the coefficients A, B, and C. By the way, this is not what you think it is. I'm not saying it's the A's in the expansion of the series. I'm just saying in this expansion for the partial fractions, it's going to work out. So if x is 0, you would get 1. Well, the first term would be 0, because x is 0. The third term would be 0, but you'd get B, or 3b. What's B? B is 1/3. I'm going to get my eraser out, and I'm going to write that down for you. We'll clean it up later. All right, now what I'm going to do. And again, this could be a dead end. I'm not saying it's going to work for you. But I'm saying it looks promising for me. It really looks promising. I'm going to try x to be, 3. The left side's 1. The right side is going to be, well, the first term is going to be 0. The second term is going to be 0. And if x is 3, you get 9c. So I'm going to say it looks pretty simple to me that c is 1/9. I'm going to write that down for you by using my eraser. And the c is 1/9. Yeah, nasty numbers, but I can still do it. Now what am I going to do? I'm going to say, I can look for another easy x to choose. And I think I've exhausted all the really easy ones, 0 and 3. I'm going to try 1. And what would that give me? Well, on the left side, it's always 1. And the right side, what would you get? Well, I don't know what A is, that's for sure. But if x is 1, what would I get? I would get times 2 if x is 1. And then what do I get? Well, B I turned out to be 1/3, right? And if x is 1, what would I get? 3 minus 1 is 2. That's 2/3. And let's see. Oh, by the way, you have an answer key. We can check our answer later. You make mistakes. You're going to make a lot of mistakes when you're working. Let's see. What's C? C is 1/9, right? And if x is 1, it's just going to be 1/9. I'm going to try to figure out what A is by multiplying both sides by the LCD. You would get 9, 18A plus 6 plus 1. Well, you're going to get, let's see, 6 and 1 is 7. 7 from 9 is 2. And A is going to be 2/18, or 1/9. Wow, that's remarkable. Let me write that down for you. All right. I actually have the first two terms of my series. Now, although they're negative exponents, it doesn't bother me too much. So what I want to write down is what I'm seeing. I'm seeing the first two terms now. Now, I'm going to erase my chicken scratch. Right? All this stuff with the partial fractions is going now. But I'm left with a far simpler problem. So my original problem now, I figured out from my original problem by doing, separating into 3 separate problems. This is what's called divide and conquer, by the way. Is I'm going to write this term down first. And that's going to be 1 over 3x squared. I'm going to write this term down next, which is going to be 1 over 9x. Again, we'll check our key later. Now, I'm looking at the last guy, and I want to tell you what it looks like to me. It looks like 1/9 times 1 over 3 minus x. And I got to be honest with you, I could do that by long division, but I'm starting to say it looks a little familiar to me. I'll tell you what it looks like to me. It looks sort of like this one up here. It's not the same one. It looks like this over here, 1 minus, and I'm going to use the letter u, by the way, which would be 1 plus u squared plus yada, yada, yada. So I want to write it that way, all right? And the way I'm going to do that is I'm going to factor a 3 out from it. And I'll tell you the number one reason I want to do that, I want the coefficient there to be 1. So let me see if I can do that. So I'm going to factor out a 3. That means the 3 is going to go with the 9, and that will be a 27. Don't worry, we have a key to check. And then if I factor out 3 from 3 from 3 would be a 1. But I got to factor it out from the x2. I think I can do that. And what's it going to be? It's going to be 1 minus x over 3. I think I'm ready to write the series down. And I'll tell you why. I know the first term, second term. I know the third term is an expansion of a series. I'll write it down for you, though. I want to get this erased. I recognize that. And I'm going to write this down now. And I can write it down quickly. So it's going to be, 1 over 3x squared plus 1 over 9x plus 1 over 27 times that geometric expand. And that's really easy to write down. It's going to be 1 plus x over 3 plus x over 3 squared plus x over 3 cubed plus yada, 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 yada. It goes on forever. So I'm going to say I got my series expanded. Now someone says, could you multiply it out for me? Well, of course we could. Maybe we'll simplify it. But I'm just going to look at the key. And I'm looking at the key. I'm looking at it. And I'm going to see what they wrote down. And I want to see if they've got what I got. So did they get this term? And I'm seeing it. It's right here. Did they get this term? I'm seeing it. It's right here. Now, by the way, I realize for a lot of students, it's kind of hard to look at everything else in the problem. But I do see this over here. I'll tell you what I'm seeing over here. X to the 0 is 1, and 3 cubed is 27. I'm seeing that right here, because it's 127 times that. What's the next one? Well, I hope you realize that 27 is 3 cubed. So what would I see? I would see 3 to the 4, then 3 to the 5, so forth and so on. X squared, x cubed. You get the idea? Now, someone says, why did they write it down that way? The reason they wrote it down that way is to see a pattern. If you don't see the pattern, no, walk away. All right, you did good. You got the series. But I definitely see the pattern now. And I want to point out what I'm seeing by that. I'm going to chase one rabbit at a time. I'm just going to chase the bottoms. 3, 3 squared, 3 cubed, 3, 4, 3, 5. I'm going to use, I'm going to use the same thing they use. Actually, I'm going to do something different. I'm going to put I equals 1. And I'll put an I here for you. There's some controversy in mathematics about using i's as counters, but I'll be honest with you, I don't find it objectionable to use I as a counter. Does that work though? Well, I get 3 in the bottom, 3 squared, 3 cubed. Yep, it works. Now what's the next thing I see? I see x to a power. I want to write down what the powers are. -2, -1, 0, 1, 2. I definitely see a pattern there. And I'm going to say there's something to do with I, because they're going up by 1. But I want it to start out, when I'm at 1, I want it to be -2. So I'm going to put -3 over here. Now let me see if that works. If I put 1 there, would you get -2? Yes. If I put 2 there, what would you get? -1. If I put 3 there, you get 0, so forth and so on. It works beautifully. So this is a good answer over here. A really compact solution to the problem. Right. I know this is a tough section, by the way. Equating coefficients is tough. Long division is tough. And what I just did was tough. None of them are easy. All right. By the way, if you want to use long division, this one over here, I don't recommend it, but you'll get the same answer. All right. You'll really get the same answer. I just don't recommend it. Okay. So what are we going to do now? We'll talk about what you're left doing. We hope you paid some attention to what was being presented by reading it and listening, if you needed to listen, and you're ready to go off on your own. Now, if I had to do this one over here, I'll be honest with you, I don't think I do undetermined coefficients. I don't think I do long division. I would be seeing geometric right away. And I do see it right away. It's really simple to see a geometric there. It's written that way. What I mean by that, looking at it, I do split it up and I write that down for you. I also write down the final sum for you. This one over here, I'm going to say I still see geometric. All right? I see that pattern. I don't think I do undetermined coefficients. And I got to say, oh, I'm sorry, they said they did by long division. But again, my first impression was, oh, it's geometric. What I mean by that, if I saw this problem over here, I would write down, 1 over 1 plus 4x minus 6x times 1 over 1 plus 4x. I'd write these so they look like geometrics. 1, 1 minus a minus 4x. That looks just like a geometric. And this would be minus 6x times 1 over 1 minus a minus 4x. I would probably do that, but I noticed it said long division. You know what? Long division does work. It works nicely on that too. First 5 terms over there. You might do partial fractions on it. I don't know. They're doing undetermined coefficients though, and I think it's a good chance to practice it. Again, they give you the problem. I do it by undetermined coefficients. I'm hoping you can remember what I've done. I do. Now, of course, long term, remember what I've done? Probably not. Short term, sure. I think you should be able to remember it. Now, long term, you would have to go back and review, all right? It's nice to have some memory, though. It really is. This over here, I guess I did geometric again. This over here, maybe long division, maybe undetermined coefficients. I did tell you I did it by long division, though. I thought it was easy. This one over here, I think I did geometric on it. Yep, I did geometric on it. I saw geometric. And what I mean by that, I saw the bottom as being somewhat geometric. That one over there, undetermined coefficients. I have a variety of tools at my disposal, and we'd like you to try those different tools, by the way. What are the tools going to be? Well, seeing the geometric would be nice if you saw it. It makes it so much easier. The other one is undetermined coefficients, and long division is really like it's the go-to tool if you can do it. It really is not bad for rationals, long division, if you can do it. If it's tough, or the numbers are crazy, if the numbers are crazy, any technique is going to be tough. So we get to this related SAGE code over here. SAGE is a computer algebra system, CAS for short. It's open source software, meaning it's free to get. That's the website. You can download it, web-based application. I got to be honest with you, though. You're going to be shocked how quick a computer do these problems over here. I mean, really quick. Any problem we feed you, it does it really quick. I mean, super quick. What's Taylor? Taylor is actually in reference to a man's name, but the bottom line, it's a way to generate a series. Now, by the way, when I say that you don't know that method yet, that method's not important as far as you're concerned. You're using what Wells was presented. But there are many methods to generate series. But I got to be honest with you, when you learn Taylor's method, you can use it, but I got to be honest with you, I would definitely go back to these methods right over here. Taylor's method is a really difficult method. It seems like it's the go-to method for students nowadays because it's easy to write down, but I'm telling you, easy to write down, it is brutally difficult to get through it because it involves derivatives, and we haven't even gotten to derivatives yet. Thank you for paying attention, though. I really appreciate that.